Good afternoon, and once again, welcome to my YouTube channel, Maths with Ease. And in this video, I want to react to a practice question on slide number 12 of coordinates, topic number 19 of Form 1 KCSE syllabus. And as usual, before you watch the video to this question or for this question, um, try to solve it yourself. Look for some graphs, construct the graph, draw the two straight lines on the same graph, and identify the point of intersection and clearly get the values of x and the value of y as the solutions to the simultaneous equations. 2x minus 3y is equals to minus 4, and x plus 2y is equals to 5. And again, verify your answer by the use of elimination method or substitution method. But the question is, solve the simultaneous equations below graphically and verify your answers by the use of either elimination or substitution method. And the two equations are 2x minus 3y is equals to minus 4, and x plus 2y is equals to 5. And I'm just having a small table here whereby for specific values of x, I need to get the value of y1. This equation will give us y1, and this equation will give us y2. So let's start. When x is minus 2 for the first equation, you realize that we are going to have minus 2 times 2, that is minus 4, minus 3y is equals to minus 4. Or if you take 3y across and minus 4 across, you'll find that 3y is equals to 0 and y itself is 0. Why 0? Because of minus 4 plus 4. So y is 0. Let's talk about y2, and that because that is y1. y2, when x is minus 2, let's talk about minus 2 for this equation, plus 2y is equals to 5. And this gives us 2y is equals to 5 plus 2, which is 7, and y is 7 over 2. 7 over 2 or 3.5. What about when x is equals to 0 for the first equation? When x is equals to 0, then 3y is equals to 4, and therefore y is 4 over 3. When x is 0 for the first one, for the second equation, you realize that 2y is equals to 5, and y is equals to 5 over 2. When x is equals to 1 for equation 1, we have 1 minus 3y is equals to minus 4. And therefore, 1 times 2, which is 2, minus 3y is equals to minus 4. And what does this give us? That 3y is equals to 2 plus 4, which is 6. And y is 2. Y is 2. What about when x is 1 for the second equation? You have 1 plus 2y is equals to 5. And 2y is 5 minus 1, which is 4. And y is 2. Y is 2. Watch this point. But just to be sure, when x is 3, for y1, we have 6. 6 minus 3y is equals to minus 4. And in this case, we have 3y is equals to 6 plus 4, which is 10, and y is 10 over 3. So we have 10 over 3. For y2, we have x being equals to 3, so 3 plus 2y is equals to 5, and 2y is 5 minus 3, which is 2, and y is 1, so 1. And those points are enough to construct a very good graph. So let's have our graph here. Let us have our graphs here, and let's see. Let's just have our graph here. Yes, that is the y-axis. Let us have the x-axis. Let's have the x-axis, and let us calibrate our graph. When x is, we can have 1, 2, and 3, minus 1, minus 2, and minus 3. Minus 3, minus 2, minus 1, 1, 2, 3. And for y, let's have 1, 2, 3, 4. And then minus 1, minus 2, minus 3. This is minus 1, minus 2, minus 3. And this is 1, 2, 3, and 4. And let us now plot our graph. When x is minus 2, y1 is 0, so minus 2, 0. Let's get to minus 2, 0, that point. And y2 is 3.5 or 7/2. So again, let's get to the graph. 0. Okay, let's first of all plot one line. When x is minus 2, y is 0 for the first line. When x is 0, y is 4/3. That one may not be very accurate. When x is 1, y is 2. When x is 1, y is 2, that point. When x is 1, y is 2, this point. And when x is 3, y is 3.1/3 or 10/3, which is when x is 3, we have 3.1/3. That may not be very accurate, but we have two very accurate points. 0, we have minus 2, minus 2, 0. We have 1, 2, and 3, 10/3. And there we go. Let us join all these 3 points with a very straight line, because it is going to be very straight. Let's have it. Let's have it here. Yes, there we go. And we have a very straight line. Now we can name that line. We can name it, what is it called? 2x minus 3y is equals to -4. That is the name of the line. The second line is when x is minus 2, y is 7/2. When x is minus 2, y is 3.5. There you go, minus 2, 3.5 there. When x is 0, when x is 0, 2.5, 2.5. When x is 0, we have 2.5 there. When x is 1, y is 2. When x is 1, y is 2. 1, y is 2. And finally, when x is 3, y is 1. When x is 3, y is 1. That point. And we come up now with a very straight line, again, joining all the 4 points very accurately. And we name the line. What is the name of the line? The line is x plus 2y is equals to 5. You can see the point of intersection very clearly. X is equals to, when you drop with this, you'll find that x is equals to 1 and y is equals to 2. So for this one, x is equals to 1 and y is equals to 2. Now, as we said, you can always verify this by the use of elimination method. Let's see if that is possible. 2x minus 3y is equals to -4, and x plus 2y is equals to 5. And let's multiply the first one by 1 and the second one by 2 so that we can balance the x coefficient. So 2x minus 3y is equals to -4, and 2x plus 4y is equals to 10. And you know, remember the dash. Dash means when we are dealing with different signs, we add. When we are dealing with the same signs, we subtract. And we are dealing with the same sign, we are subtracting. So we can subtract either this way or downwards, but I prefer upwards, so that 4y minus 3y, we get 7y is equals to 10 minus -4, which is 14. And you can easily see divide by 7, and y is equals to 2. Our value of y is equals to 2. So if we substitute this y in any of the equation, for example, the second one, you'll find that x plus 2y, which is 2 times 2, 4, is equals to 5. And clearly, x is equals to 5 minus 4, which is 1. So it has been verified that x is equals to 1 and y is equals to 2. Thank you, and let us subscribe to the channel and let us hit that bell so that every time we upload a video, you will be the first one to be notified. Thank you. That is the end of the topic number 19. Let us be on standby for topic number 20. Thank you.